Welcome to the 10th video in the series of video on current electricity. In this video we're going to do a problem by putting all that we have studied together. So we have the circuit and our objective is to find the current, net current in the circuit, and also to find, hey, what is the potential drop across each of the resistors. So the potential drop across these two resistors will be V12. They will be same, and we know that the potential drop across these would be V345, which will be same because they are parallel resistors. So our objective is to find the potential drop and also the current in each of the resistors, in all the resistors. So the first step to do to follow when you do these kind of problems are to draw the potential diagram. So imagine you are this 1 coulomb and you have gained about 1.8 volts as you pass through this points, which is AB. You have lost both the resistance have lost about V12 volts, and further you can mark these as R1 and R2, and further you have the other three resistors also contributing to the loss, which is R3, R4, R5, R3, R4 and R5. Now all of this have contributed to a loss of V345. Okay, so that's how you look at this. Now the first step is to simplify or find the net resistance. So always the first thing you got to do is to find the R net. And how do you find R net? First let's look at 345. So 1 by R345 is equal to 1 by 30 plus 1 by 20 plus 1 by 60. That will be 2 plus 3 plus 1 divided by 60 as 1 by 10. So you have R345 as 10 ohms. Similarly, you can do R12. We can use shortcut for R12, which is R1 into, or maybe not. Maybe we will do it the normal way. So 1 by R12 is 1 by R1 plus 1 by R2, and that is 1 by 10 plus 1 by 40. That's equal to 5 by 40 or 1 by 8. So you have R12 as 8 ohms. So your R net would be equal to R12 plus R345. That is equal to 10 plus 8. That's 18 ohms. So your first is you have found the R net. The second thing you need to do is you need to find what will be your I. So your I is E by R net, and your E we know is 1.8 volts. 1.8 volts divided by 18 ohms. That's 1 by 10 amps. That's 0.1 amperes. So once you get this, I think every other thing can be resolved. So you have V12 will be equal to I into R12, and that will be equal to 0.1 into, we know that R12 is 8. So that's about 0.1 into 8. That's equal to 0.8 amperes. So this is something you can resolve. Similarly, you have V345 equal to I, the same current I that is passing through, into the equivalent resistance into R345, that is 0.1 into 10, that's 1 amperes. And your so I is equal to 0.1 ampere here. So you have found V12 and oh sorry, this is 1 volt, not 1 ampere, 1 volt, because we are finding the potential drop. So we found the potential drop. So this is 1 volt and V12 is 0.8 volts. Here also, this is also 0.8 volts. Once you do this, then you can find out the current in each of this. For example, you can say, hey, I1 equal to my V by R1, and the V is 0.8 divided by 10, so that's 0.08 amperes, and your I2 would be V by R2, that's 0.8 divided by R2 would be 40, that's 0.02 amperes. And you can see that these two will add up to your 0.1 ampere. So similarly, you can do it for the rest of the resistance. So I hope this video made sense to you. To end this, I would urge you to do a problem, a question that you can try it yourself. The second problem in this which we do is, let's assume that you have a 2 ohm and 2 ohm, and you have a 4 ohm resistor, and a 3 ohm resistor, and you have 2 volts. So find potential drop and current in all the resistors. So find PD and I in all resistors. Your answer should be, your I will be equal to 0.25 ampere, and your potential drop across this would be 0.75 volts, this would be 1 volt, and this would be 0.25 volts. They all add up to 2, and this answer should be about, if this is 0.25 amperes, it will split up equally because they are equal resistance. So 0.125 amperes, 0.125 amperes, and rest of them all would be 0.25 amperes. So check out your answer, do your working and check out your answer. I hope you enjoyed this video. See you in the next one.